Right. Good afternoon, everybody. Is maybe the last lecture in the series of this course. Today we're gonna talk about the subject of agility practice in the industry mainly, and some automation in the General Motors. The project is motivated by many aspects. We talk about agility in general, about software development, and the agility community now is becoming the mainstream rather than the exception, like 10, 15 years ago. Nowadays, it's becoming the standard, especially the Scrum practice and the best practice in software development. We talk about the traditional software development. And when you talk about software product line, then it becomes more interesting because of many motivations besides the original ones of developing things in iterative manner and to do fast and quick cycles of software development for the purpose of continuous delivery and deployment, continuous testing. So today we are going to touch on this subject when it comes to agile product line development and software product line engineering. And we're going to see how it's important that the pressures on companies, especially large ones, to migrate from the old standard sequential long cycles of software development to more dynamic, agile, short cycles and sprints of developing software in increments and being able to test it in real time and to be more responsive to the stakeholders' requirements, as we are in a very competitive landscape in the industry. You may know that things change. And change is the only constant in this industry, and the issue of capturing requirements and freeze the scope was something from the past. Nowadays, you as a developer should have an open mind mentality when you deal with the stakeholders. Stakeholders are everything. They are your customer, they are your users, they are your funding source, they are the bosses that who would just turn on or off the whole operation. So being responsive to these pressures and keeping the house in order, making sure that the quality is being delivered in the sense of complete high quality testing and the reliability of your product. All of these pressures and changes demand on modern companies to be responsive and develop agile practices and make sure that they have always continuous requirement elicitation and continuous development in small cycles and delivery and deployment as they test every increment of their product. Having said that, so today we're gonna talk about the agile product line engineering, and then we're gonna talk a little bit about industry practices and some automation at the end of the lecture. So keep me aware if you have any chat questions there, and I will keep an eye on the chat. Okay, so let's have a quick review on the issue of agility in general. So we talk here about product line architecture because it's the first step usually in any development is to design the architecture. And the problem here, there is a conflict that many people would notice when we talk about software architecture in general. That is, the assumption is always given to us that you have all the time and all the luxury to go into review and collect your requirements, and then start thinking of what's the best architectural design, and then you go think of all your tactics and things, as if the whole world is frozen waiting for you to finish your product and deliver it. That's not the case. If you want to be agile, you have to be tolerant to change. That's the main key word, change. So in short, you cannot develop a complete architecture without some noise and disturbance and changes and requirements that keep the market changing and dynamics change with the stakeholders. So to be agile, that means to be responsive. We need to look at this conflict and see what are companies doing to resolve the conflict of not being able to complete an architecture design per stakeholders' requirement when keep it changing. Because this is important to be responsive and do things change and this change as it happens without disrupting your pipeline. We talk companies, large companies have this really more chronic problem. In a small company, you are very close to the stakeholders, maybe very limited in number, maybe one or two, and then you can communicate and understand, and then you're large, and it's not really difficult for you to respond to change since you are small in size. You are large, and your agility would be a challenge. You would have issues related to communication, to management, to handling all these issues that would come from all angles, especially when you have large development team and large number of stakeholders. We need to look into a suitable framework to develop our software product line in an agile environment like Scrum, and be able to respond to the changes that happens in the industry. So as a quick review here, what is agile software development in the traditional sense? These are short iterations, as you know, to develop the product in increments and have continuous delivery and continuous deployment in collaboration with all stakeholders. And this issue of collaboration is extremely important in this regard. So some big companies really thought of scaling up the agile framework, and they came with what's so-called scaled agile framework, SAFe, and Scrum of Scrums, SOS, and so on. These are modifications, little modifications to the agile framework, like Scrum, to accommodate the pain areas that large companies, large teams of development have faced, like we will see in Lockheed Martin example in this lecture, what type of challenges they will face that is not present in a small companies. So you see in this famous diagram, you see the Scrum cycle here and the sprint being developed in increments. The products are being pushed out of the pipe in increments of small sprints. And then you have the daily Scrum people would meet and decide if the product is finished and what is next and what are the lessons learned and so on. So this is just to refresh you on the issue. And we have the Scrum roles. We have usually in your development pipeline a product owner, and you have a Scrum master that's managing and supervising. You have development team, of course, and the stakeholders. Stakeholders are very important, and the whole thing is done to serve them. So we have also the Scrum artifacts. We use these jargons like a product backlog and sprint backlog and user story and task burn down chart to show if you are on time delivering things and doing it per plan. And you have embedment backlog. If you have problems, then you have issues, and you have yet a clear definition of what is done in terms of completing the tasks, including burn test and all that. Also, Scrum meetings, weekly sprint meeting, one sprint meeting, daily Scrum, sprint review, sprint retrospective, so on. So just to refresh you on these terms, where you heard it a lot in different courses. We're gonna talk a little bit more about Scrumban, which is a combination between the Scrum and the technique to a process that is helping many companies form from traditional to agile practices. So we will see this would lead us to we want to ensure that when you transform from the traditional practices of sequential software development, large teams or large chunk of development to smaller teams and ability to mobilize small teams of specialties and the product on time without much. As you see in this culture here, when teams developing their things in sequential, this team, the other team finished with it, the other team, this is totally non-agile, cause problems of communication, problems of backlog, feedback loops, disruption of.
Sorry, there's a lot of issues with the audio.
Audio has a problem?
Yes.
Just a minute, let me see. How is it now?
Much better.
I'm sorry for that. Maybe my headphone speaker was on. Maybe you were hearing me from the headphone. Is this better now?
Yes, it's much better.
I'm sorry for that. I hope everybody heard what I said, but anyway. So I'm just trying here to give a quick introduction to the agile practices because we're going to use these terms and jargons when we move on to talk about product line development based on agile practice. Okay, here are some metrics to understand why people are interested and keen to move totally to the agile practice, whether in single software product line or in the development of the complete product line per domain development as we know it in software product line. If you notice here in this chart, you will see the cost on the y-axis and here the activities on the x-axis, and it shows you if you use like a process like waterfall or a sequential development product in the legacy structure with big companies, the problem here, especially when you go into the areas of completing the coding and the testing, things will shoot exponentially in terms of cost and even in times, delivery time. And the agile is represented here in the red line. Yes, it will increase in cost, of course, as you go into finalizing your code and testing. But however, in the long run and in the intermediate level, there is a tremendous saving in terms of cost. But don't forget that also equality is very important. And you can see here the quality issue more in this chart. Here is a comparison between small projects and large projects. And in small projects, you don't have an issue. You can maybe get away with doing less agility and get away with doing these small iterative things because the whole project is small anyway. And your risk is minimal. Here we see like 4% of these small projects would fail, regardless whether for agility or not. But this is a small project. The problem here in the big projects, if you don't follow these techniques to optimize your operation, you can see here about more than one third of the projects would fail, and only 10% of them successful. And more than half of them are challenged. That means there is a problem with quality. So agility becomes more
important and more emphasis on following its principles when it comes to large companies and large multifacets projects. So this is why we are going to focus more on large projects, large companies, because this is where the gain is going to be the most. Okay, we'll first introduce one framework, agile framework for product line, and then we will talk about others and get you to understand the whole structure of agility. And this framework would help move the teams from the classic approach, as we mentioned, maybe waterfall or whatever, to more evolved agile product line engineering framework. It uses what we call goal-oriented requirements, GOR engineering, goal-oriented requirement engineering approach, and also it implements as an initiative process for Scrum-Ban. Scrum-Ban is, as I said, a combination of Scrum and Kanban. The Japanese also pioneered this process for quality engineering and for agility. And we know that GOR has been used for requirement engineering in particular. Also, it's been used for business processes and organization impact analysis and software process modeling. Okay, so this is the framework that a large company would use for software product line engineering, and we are gonna discuss it in its entirety. We're gonna take the problem domain and the solution domain for both the feature engineering. When we talk about the domain engineering, we're gonna discuss the problem side and the solution side, and also in the following slides, I'm gonna comment on the application and the development and the derivation of the products themselves for individual software in the application domain. So let's talk here about the domain engineering side. The problem, this is the domain engineering, and we're gonna talk about the problem side, the problem aspect of it. As you see from the diagram, it all starts here in the domain requirement engineering, start with software vendors. Here is the software vendor that will decide what needs to be done. And then you have here your stakeholders that are gonna decide to develop the business strategy of what they want to do and what they want to develop. Of course, they are in the domain now engineering. They're trying to find a modeling the domain side. Step 3 here, it says do the domain requirement engineering. So you see here, the strategy is being spun off, and they use also agility in developing their strategy as an artifact, because in Agile, you treat everything as an asset, and you don't just look at the code or the software. So there is here a Scrum spin in developing the strategy and identifying what they want to develop as a domain for product lines. So the domain design in step 4 gets completed and derived. As you see it here, they push the requirements, and the domain design is being developed here in this stage. And once you have the domain, then you are able to do the feature domain diagram. And the feature modeling is done in this stage, stage 5. And then you develop here what's so-called the feature backlog. The features backlog is equivalent to the sprint backlog in a single product line. So you have all your features being developed here, because in Scrum practices in software product line, you look at each task to be completed in terms of features. And we're going to talk less, more important about feature-oriented design. So the feature domain, the feature modeling is translated into feature backlog, and you have it here. And then from there, you go to document the feature into user stories. So you get here into user stories, and you plan your stories because some features are large. You have to decompose it into different stories to be able to push it to the development team to finish it. So not necessarily all features are gonna be represented in one user story, because user stories, the cycle for development of user story is usually 2 to 4 weeks at maximum. In step number 7, you define selected backlog, and in number 7, you define selected backlog in this meeting, and development team here structure the user stories and put it in a backlog that called stories in progress, SIP backlog. These stories here are the ones that are going to be pushed down to the team down. We will see it in the second slide, to start development of these stories one after the other. So this is how agility is being practiced. So we notice from this slide in general that the strategy is being developed, the domain modeling and feature modeling took place first, and then we developed a feature backlog, and then we translate these features into, or decompose them into user stories. Then a development team examine these stories and put them in priority order in a backlog that is called stories progress, stories in progress, SIP. And this is the backlog that we want to leave this slide with. And then this was a planning meeting 1 that sorted these stories. Then we moved to planning meeting 2 to the application domain. I will move to the second slide, but let me see if there is any chat issue here. Okay. All right. Yeah, that was about the noise. Sorry for that. Okay. So let's move now. We are in the domain problem space. We're going to move now to the application domain. And this is the solution space also. We are moving from the first quarter to the second one, from the problem space to the solution space, but still we are in the domain area, not at the application itself. So now we move to the solution space in the domain engineering area to develop further our features. So step number 10, we said we go to planning meeting 2. The team establishes the production flow. This team here is going to establish the production flow, which is going to also prioritize who is going to do what. Then you have your daily scrum to plan and look at the problems and see what has been done, what needs to be done, and all that. Daily scrum is here happening in almost parallel with planning 2 to identify what has been accomplished, what's been completed, what is not, and so on. It's a planning meeting for, as you know, the daily scrum and daily stand. And the team would hold a review meeting to review the work accomplished, pass common assets to the warehouse. Here, they pass the common assets to the warehouse. These are the sprints that, or features that has been completed. They are cataloged and reported to the common assets. If you remember, you have your assets being developed in product line engineering so that they can be used or reused in the future for any product line. The artifacts, sometimes we call them the artifacts. Then in step 14, you hold the retrospective meeting, which is here to see what is being done and how we learned anything that we learned from the past and any problem that we faced that we should do better and all that for quality engineering. Here, the SIP story can be pushed if it needs only further testing. So you can here, if you are not comfortable with the feature or the sprint that being developed or the user story, you can push them back to the team in the domain engineering to look into it and fix some stuff and push it back in the pipeline. So there is a feedback here, and that's what's nice about agility, that you can incrementally look at things, deploy or recycle or send it back for further development. So the feature can consist of multiple user stories, as we mentioned, and at the end, this is our goal from this whole process, is to send and deliver completely tested products to the common assets, to the artifacts that we're going to use in our feature build in the future to develop new products and the new software. So this is roughly what entails in this agile framework for product line engineering. If you notice that usually these activities are done in normal situation, but not in these cycles of small incrementals. Traditionally, companies will say, okay, we need a feature, and then they assign a team to develop a feature, and it takes maybe a couple of months, and then they will take it back and test it with other products. And the complexity, we're going to talk about that, of doing it the old way is going to be very toxic, because any changes in these features here in the common assets could impact other features, could impact, especially if you don't have well-isolated, modular, decoupled features, as we were talking in previous lectures. So now we move to the solution domain, application engineering solution domain, and see what happens to the process. And this process here start with the application owner. The application owner is here. The processes start here with this application owner and the requirement engineering. This application owner would push the products to these people that every one of them here, we say application I owner, which means like 1, 2, 3, 10, whatever, how many applications you want to develop. Now we talk about individual applications being pushed from the feature assets that we have developed before. The application owner will be pushing, and each one of these, we're going to take you a journey through one of them, going through developing the product at the end in the traditional way, like they are developing a single product. And there are two types of features that coexist in this process. Let's get to know them and see the difference. The features exist in common asset warehouse. The common asset warehouse called selection of features, SOF. Selected of features means that these assets are completely tested, completely accepted, and cataloged within your assets and artifacts that can be used in your system. So we can say, in short, they are complete, acceptable, fast, reusable artifacts that exist in your assets warehouse. When there are features that are to be developed, called definition of features. As you know, in product line engineering, the first thing, as I talked in the previous lecture about implementability, you look first to the assets you have, the artifacts, to develop your product soft line. If you find the the feature or the artifacts, that's fine. You take it and include it in your product. If it's necessarily needed and it's part of your software development, but it's not there, or you might have a feature that is closely resembling what you want, but it requires modification. At this point, you push this into your stack called definition of features, DOF. So in the definition of features, you will be able to send it to a team in the agile process to start developing this DOF to include it in your product development. The DOF will move to the application engineering solution domain for development. So you will see here two routes after you have your application backlog, and you have two types of features. You have the DOF, the SOF, sorry. You have the selected selection of features. These are completed features. And you have here the features that you will need, but they are not completely developed, which is called definition of features, DOF. So what you do here, you send the SOF, which are completed, you send them to the reusable artifacts. It goes to your warehouse, to your assets. But if it is not developed, you push it down to the product line configuration to develop it further, as we will see in this chart. So it comes here. These are the features that are not fully developed. You want to put them in sprint planning, so you can put a sprint backlog like you did before to develop these features here and take them through the sprint execution and a sprint review, and then you push them out. So what is happening, definition of done also, we have a term here, DOD. When it is completely done, you send it to your assets back, and also you have the sprint retrospective, like you do every time you finish a product, to review and manage future backlog. So we see here that whenever you have a product that needs to be developed, you push it to the team and you develop it as a singular product in an agile process and complete it and push it back to your assets. So we are saying that in this agile framework for product line, and it was iterative everywhere you looked at, whether you were doing and developing your feature domain, and in the feature modeling area, you used agile. And then when you pushed this to features, you use agile to develop from features to user stories. And then you took your user stories, you put them in the backlog and develop them also in, using the Scrum practice to be short, iterative, and test on time and deliver. So this is how it's been proposed for large companies developing a software product line to do it in the agile practice. Before I move to the second part, let me see here, what do we have in the chat? No questions. If you have any question, please slow me down and I will go back to it. Okay, so this is one way it's being done. And we can look here at the agile product line architecture. We haven't talked much about the architecture, but I started at the beginning of this lecture saying that the big issue is the architecture. It's not the actual coding or the body of the software, but rather the architecture that will dictate the whole structure of your software. Architecture is very important because it's the guiding tool of how things will sit together. And back again, I need to remind you, we are not talking about just coding. When in product line engineering, we are looking for all the artifacts, all the assets that will contribute in producing a meaningful product. I mean, in big companies, they talk about documentation, they talk about testing, they talk about even design decisions, when they were taken, who took them, why they took them, what's the wisdom, where we were moving, what were the motivations, how we are going to increase usability, how we're going to improve testability, how we're going to do with the power. For example, in mobile development, like in Apple company, power dissipation and heat and management and reliability and managing the ecosystem of suppliers. And I'm going to talk in a short about this, because in large company, there is an ecosystem of suppliers and you don't develop everything in-house. Remember, in big companies, when you build a product, maybe there is, I know, for example, Lockheed Martin, they have like 10,000 subcontractors. When they develop, let's say, a jet fighter, they have 10,000 subcontractors and they need to manage them. They get artifacts from them. They need to automate the process. They need to make sure everything is delivered on time. They need the documentations. They need the knowledge. They need to understand the changes from last time, any update, any changes, testability, how it will test after it interacts with other systems. So complexity is beyond imagination here. And let's talk a little bit about the architecture. So we talk here about agile product line architecture. And APLA or APLA is the integration of a set of models for describing, documenting, and tracing product line architecture. So the talk here is about the architecture. Of course, it will talk about the algorithms that are contributing to this architecture and the decision-making that follows this architecture. So in this process, the product line architecture would be requiring the following. It would require you to incrementally and iteratively design the architecture itself, and to be open-minded to change. As we said in Agile, if you are an architect, you cannot just sit in your silo and fantasize about an architecture and develop it. Yes, you might develop it incrementally, but you have to watch out for the changes that come from all angles. And this architecture has to evolve in each of the iterations to incrementally include features and products. If you are dealing with an architecture that has to evolve in an evolution process, not because it's bad architecture or has problems, because this is the name of the game, change. There will be new features, a new technology, new demands, new customers, new stakeholders, a new market reality, competition, God knows what. So when you design your architecture, you have to make sure it's evolving architecture. It's an architecture that can be extensible. And we talked in some features in the architecture that enabled your architecture to be reusable, extendable, and decoupled. So here, the objectives, these are three objectives. As I mentioned, we need the flexibility and adaptability. That's important in developing the architecture. We need to facilitate a change in incremental phases. We need to facilitate architecture concerns. If you have some concerns like dependency, you need to rationalize. You need to look at the constraints. If you have power constraints, security constraints, whatever it is, you need to look at all these risks and the stakeholders' requirement. This all will impact the design. But the key word here is a change, and you need to build a flexible architecture that is liberal in terms of responding to change requirements. For that, there is a research effort has been done to add extensibility to your product line architecture. And one of the techniques here used is using what's so-called plastic partial components. Don't worry, this is not going to cause pollution. They use a plastic maybe to refer to elastic. But anyway, that's the name. Plastic partial components, PPC, are being used to address the agility and the ability to respond flexibly to your architectural design and be able to create variation points. If you remember, this is look like the aspect we talked about when we talked about modularity. You add an aspect which allow for you to do a variability point to extend your design and do changes, add, remove features, and so on. It allow you these what's called plastic partial components to add variants and weaving. You weave variants or unweave variants by adding, removing features to the design. You can use these weavings from outside of your architectural model, so it will not impact the coupling, decoupling. You are not really tampering with the inside. You are keeping your features abstract. So if you have a reusable feature in your assets and you want to create a new feature or modify it without destroying the feature in its originality, you come and add these PPC to add variants. So we'll see in the following slide how this is done. Okay, so here, for example, in this model of PPC, you are adding what's so-called extensibility point, extension point to a feature by adding this weaver. We call it weaving one, and through this weaver, which you can call it like a broker, but it's an extension using PPC technology, you can have variants. These are variants which are, let's say, addition, modifications to an existing feature. But pay attention, also part of this design is what you see in B. It's important. Big companies put a tremendous importance on documentation. Along with the design, and they consider it part of the artifacts, is to explain here. It talks here about why, what's the cost, what's the risk, what's the trade-off. And by the way, this is just an example. You can put anything you want as an attachment to this PPC to explain open design decisions, why these design decisions are taken, because in the future, maybe 2 or 3 years from now, another engineer will come and look at that and say, what the hell is this? Why this feature has been tampered with? What has been changed? And instead of coming here as another engineer and put another PPC here to the variant, they might scrap all of this and start a different variant and keep it clean. So I'm telling you, when you deal with hundreds of thousands of features, it can be very messy. If you are not very careful of where you added this PPC, what features and variants you added, and how you documented that, then you will have a problem to understand the mechanism of behavior of this extension and be able to flexibly change this in the future. This is why we are doing it the way it's done here, and it's documented. And documentation, as using some tool like DOORS in GM practice, they use specific tools to document these things and make it handy to their engineers once they want to understand what's going on. So all these tools are there to make agility for your architecture handy and flexible. So we talked about the first objective of agile product line architecture, which is to describing flexible and adaptive architecture. And I think I covered this to explain why we need this. So let's just move in to objective 2, which is documentation, the flexible and adaptive architecture. And they have, in that sense, to rationalize the architectural decisions. As I mentioned, any decision that was made for developing a feature or adding extensibility for it, they put the rationale why it's done, so that a new team as you remember, we are working in small teams now, need to know and understand, and then can manage further this feature or asset. So these knowledge involve like design decisions that drive the architecture solution and their dependencies and rationale. And in that concept, they have the product line architectural knowledge, fancy word, PLAC, and it provides the documentation and the design decisions with the variations and the capabilities to trace and give you the history of what happened to the artifact. Here it's showing you a PLAC, how it is done with an extension point, whether using aspects or using PPC. And here it talks about an extension that was aimed for availability. And here it shows about strict, non-strict, and explain about the cost and the risk and the trade-off, what type of a trade-off the design decision engineers made. They trade off maybe performance for cost, they trade maybe complexity for time delivery, and so on. So by the engineering understand the design decisions justification and motivation, then they are able to manage the product properly and keep it clean and usable for future engineers. That's mainly the motivation of this effort. Okay, talking about the process, the Agile team, they are able to track all the architectural concerns and constraints, risk, and viability. This way is very critical when you come to agility and development of customization. They are able to use a Scrum and the sprints to divide it into two domains, as we mentioned before. You have the engineering domain and the application domain, and we can see this in the following slide. This is now implementing Agile product line architecture. So this is an Agile process driven now by the architects. If you see here the architects, those nice people with the hat and the drawings, they are the driver of this process. When you design your domain engineering and application engineering, it starts with the architect here that is going to develop this friendly architect that is friendly when it comes to agility. So you can see here what they are developing. It's called the Sprint Agile Product Line Architecture, APLA. So this is what they do. And then you have the Sprint Product Line Owner. These are the people who are just focused on a specific product to develop. And you have the Sprint Planning team. So all of them are in this box. And the outcome, the real outcome out of this process of domain engineering is to look at the change impact knowledge and the flexibility of the PLA. If there is any change in the architecture, if there is any issues related to the flexibility and the extensibility of the architecture, they will take it back and review it before they put it in the sprint backlog. So in this design, you make sure at the domain engineering level, when you start doing your feature modeling, that these designs are flexible, these designs are extensible, these designs are more friendly with the agile practice of continuous delivery and continuous deployment. So here, from here, if you take it from here, it continues the same way like we looked before. You have a sprint backlog, and it goes into the 2 to 4 weeks sprint cycle to produce a working product line architecture. So at the end here, you have your architecture, and from the architecture and the working products, you remember you have your assets, you can develop further your application product line. So this is just to show you how some modifications here to accommodate agility at the architectural level. We will go into this summary, but I'll check the chat. If there is nothing, we want to give you maybe a little break, and I will come back and give a summary for this and go into the next topic. Maybe we will be back in 20 after the hour 2:20. 2:20 we'll be back here. Thank you for your patience, and we'll see you then. Thank you. Okay, we are back. And if you have any problem with the sound, let me know. We ended here trying to summarize the process of agile product line architecture. As we mentioned before, this is focused on watching out any impact of variation of your architecture on the development team. And it starts with the product line, software product line backlog. And then the architects would analyze this working product line architecture. And through the sprints, in this sense, the sprint here is to develop or look into and analyze the product line architecture. They use what's so-called the change impact analysis algorithm to study and understand if there is any feature that being added or modified that will impact the behavior of the system and what type of impact these changes would have on the other artifacts, like testing, like performance, like further impact on other features that may be somehow coupled to the features that been changed. And then they make some decisions here to prioritize the features based on their impact. For example, if there is a feature that impacts the system and slow down the system in a big way, if you remember in the knowledge area, there are risks and cost and trade-off. If they see that the trade-off is not justifiable, then they go back to the stakeholders and explain this impact and make some decisions to include or exclude or further modify the feature. So this process is very critical in developing new products and expansion and extensibility of the software product line, in a sense that we don't want the new features that were implemented or added in good faith to improve the product line that now have an adverse effect on the overall performance, or it might impact areas that the designers did not see. So this process is critical before you proceed into further development of your products in the solution domain under the application engineering. Before that, as we said, as an architect, you need to investigate this impact and do the proper analysis. So this, the first step, as you see here in the diagram on the left, this is what they do. This is the software product line. And this is here where they make these decisions using impact analysis. And then here they push the product all the way to the application engineering, or they go through a planning meeting and do a sprint backlog and do some fixation for the software product line before they push it to the application engineering. So all this activity here is in the domain engineering, and it has to do with the whole software product line, and it investigates the impact and the interaction of features within the complete software product line package. So in step 2, the features assigned to the sprint are incorporated in the working product line architecture. So if they pass all this scrutiny and they are okay, they are not impacting or adversing the performance, they are included in the working product line architecture backlog. And there are other techniques that are used here. We call flexible product line architecture and modeling primitives. And they do it in iterative and incremental manner to evolve eventually with the product line architecture that is acceptable and can be pushed to the application domain. Here we also, as we said before, they use product line architectural knowledge modeling primitives to document and trace the design decisions as part of their integral duty. When they approve or finish scrutinizing the architecture, the documentation and justification and all these things, including dependencies, constraints, trade-off, and all that gets documented in the black modeling primitive. And some companies use a specific software to keep this database that is attached with all their artifacts. Okay, this would make me move to show some practices in the industry of, for example, there is a case study for Lockheed Martin deciding to move towards agility from their old practices. And we will go just in a quick journey to see what they have done and what are the results. And in this case, as you may know, this company is large and they have so many products and so many suppliers in their ecosystem. Their vendor management is a nightmare. Any system they are building has like thousands of subcontractors, and there is no product that can be developed in-house by one company or any. When you talk about assets that they need to use or reusable artifacts that they want to use to build a system or a product line, it's extremely complex. The management itself a nightmare rather than making a change or modification. So you have to appreciate where it's coming from. And they use Gears software product tool for automating their product line engineering. And we will talk a little bit about how they do the designing model and develop their code and their testing nightmare, how it's been done. This shows you here a quick symbolism of how the product line engineering factory works. They use even the word factory to make it look like a assembly line. In this side from the left, you see all the artifacts and the assets coming, regardless what it is, from requirement engineering to feature modeling to codes to all of these things. They come to their configuration management here. They call it the gear. The product configuration use some guidance on product specification. They call it the bill of features. The bill of features here define the specifications and the variability points that needs to be applied to these artifacts to produce a new product line. And we will go maybe in more details in different diagrams to explain this process. Okay. Let's see if anybody in chat. No. All right. There are some terminology here. Maybe it's helpful so we can understand how they use the terms. They call a member of its product line configuration, a configuration. So a configuration is an instance of the system to be developed, deployed for a specific platform. Now, be careful, configuration here is not a single software product, like we know in the other terminology. But a configuration here is a group of software, it's a product line of software that is geared towards specific application. So still they can apply variability and commonality and come with a new product out of this configuration. So let's just use this term configuration to refer to a product line of software. And this product line comprises roughly 100 such configurations. So you can have also a product line of a product lines. So they have a product line that has maybe 100 configurations. And under these configurations, they can have different instances. And here it says each configuration that is deployed to its final operational user community comprises 9 major software components. So in each configuration, there are 9 major software components. And when we use the word major, then there is minor. They are all working together to achieve a functionality for a full system. So they bundle these products, let's say 9 products, into one configuration to develop an application, to develop a solution. So this is just little terminology to get you aware of that. So this produce or generate a nightmare of management. How are you going to manage all this hierarchy and make sure that they keep documentation and everything? So we say the product line employs a common specification repository tool. They call it DOORS. I think it's an IBM tool. It's known in this field that it keeps track of all these artifacts, from configuration to products to software group. So it's a database that would keep for Lockheed Martin all their assets under control and well documented. So it has the requirements and the configuration, and it captures also the feature-based variation points. So it's very important that any variation activity, any variability design needed, they have to go back to DOORS and get this information to act on it. So this would allow them to have multiple configuration to share requirements. You can have maybe 100 of configurations that are using a specific requirement. So it's not like one-to-one mapping that for every artifact, they will have a complete set of documentation. And this is very critical for testing and tailoring regression testing based on changed functional areas, common test efforts, and development. In regression testing, it's when you have such complexity of hierarchical products and you do any change, let's say you change a configuration code or artifacts, God knows what, and then you need to test it. It's not simple like that. You can just go and test what you changed and say, okay, everything is working fine. Let's roll it and put it in the system. They have to do regression testing in a fact that by reviewing their documentation at DOORS, see this change. Remember the issue I talked about, impact analysis, to see the impact of the change on other products. So to see if there is no coupling, great, but if there is always going to be some coupling somewhere, that some artifacts will be affected and it would require testing. And that's what we meant by tailored regression testing. So don't take lightly the issue of testing, because they have to produce fault coverage of 9.9999, which is like 5 or 6 nines reliability on their test coverage to make sure that they deliver highly available, high quality products in terms of software or artifacts. Okay, so Lockheed Martin in 2014 decided to start moving aggressively to the agile practices in their software development, from being largely a legacy product shop. And then they were faced with a management nightmare, because some of their products are like in tens of millions of lines of code, and the testing artifacts hundreds of millions of dollars cost in their single products. And they have a spread team because of the talents issue. They have like 200 engineers might be working on one product line, and in total of 800 engineers involved in the production of configurations and things like that. Also, not only the complexity on the stakeholders and the people involved, and the bureaucracy of communication across them from different departments, they also have an issue related to the timing, delivery, because they have to synchronize every subsystem to deliver on a certain time and converge to configure and assemble the whole product. They have also an issue that their product line had a cycle of 4 months. As I said, it was a legacy. Now in Agile, 4 months is not acceptable, it's a waste. They have to reduce it now to 2 to 4 weeks to produce products and test them. And this is the big benefit that LM will take out of this conversion. So the migration take place, and they had to bridge this gap of large scale product line engineering and to small scale short iteration agile. So how they did it, they have made two major changes in their operation. They reduced the teams from 200 used to work on a product line to small teams of Scrum teams, as you know, size 7 to 10 or whatever. So they work together, and they were able to shorten the iteration of the schedule. And we will talk about this, the time frame that they used to do 4 months. Now they're gonna go lower. And they gave autonomy to the teams, because in a Scrum, you cannot tie the hands of the teams. The teams are autonomous in a sense that they can make decisions, they can design, they can do whatever they want. They want to be innovative. There are guidelines, of course, and constraints they have to follow. So they are all like, the team is designed to have all domain experts, self-contained. They have the architect, they have the developer, they have the coder, they have the designer, they have the tester, they have all these things. They don't go into a pipeline like the old way. This is just showing you how their Scrum was developed in more details. Like they have 5 to 9 people in each Scrum cycle. They have a cross-functional in each team, and software engineers, the testers, the database, system admins, user interface, and so on. They have full-timers. It's not like somebody just visiting. And they are self-organized, self-managed, as we said. And this is how it works. Co-located, sometimes not all in the same place, but still they are one team with some leadership and structure being implemented. Okay. So now you said you reduced the size of the team, but you still have big problem to solve, big systems, lots of configurations. Now they ended with hundreds of teams, of small ones. Now there is a nightmare of how these so many teams, and some of them are fragmented in different geography, will be able to communicate and synchronize their activity. And this, we want it to be done without wasting much time in just communication. So communication becomes a concern here, and how they will streamline their operation and synchronize it. So to address this problem, they went into what's so-called scaled agile framework. SAFe, as I mentioned before, when you have a large company, you have to scale your Scrum to handle this large number of people involved and large operation. You need to have a very flexible, advanced knowledge base for implementing agile practice at enterprise scale. So manual things will not work anymore. Your documentation have to be available anytime, any place, and easy to access, easy to reference. This is why, like, they use doors. And the definition of roles and the definition of communication and all these things would have zero tolerance, so that you will not waste time trying to communicate or argue across the teams. Then, after solving the issue of the teams and making them small and agile and self-contained and independent, they came to the issue of small iteration. Now we want to move from a cycle of 4 months to 2 to 4 weeks using SAFe, Scaled Agile Framework. And to be able to have this small iteration, you need to divert from classic Scrum. We need to bring this sprint activity into 2 weeks, and and also to be able to do continuous delivery and deployment that means incremental testing, that means incremental control, and so on. So the issue was dropped from 4-month release cycle to 8 sprint release. If the sprint is gonna take 2 weeks, that means 8 sprints will take 2 months. But still, each sprint is independent and they are able to deliver in 2 weeks products rather than 4 months. Yes, they are small and incremental, but meaningful. So they have also divided their sprints into user stories. They try to tie the user story to the feature, like we said before, feature-oriented design. Feature is a sort of large-scale user story that complete within a release. So if they can tie the release with features, a feature can be implemented in different user stories. Let's see if anybody has a question or comment. Okay, could you relate feature with an epic in this context? Yes, there is a slide coming onto that. I will show you how they divide their epic into stories. And epic is just large number of sprints and sprint stories, and then you have tasks. We will show this, I think, in the following slide. Yeah. So in Lockheed Martin, we said that the tempo is to move from 4 months to 2 weeks sprints. So you can look here and you see that we said the user story could be one user story per sprint or several user stories per sprint. But they use this terminology. The user story can be further divided into tasks. The task is usually, I think, a couple of hours, 16 hours here. Maybe the 16 hours are for tasks. And then you have stories. The story can be done within a day or 2. And then you have the sprint. The sprint comes associated with the feature. So here, for example, the epic spans multiple releases. Other major capabilities or type of work, large user stories can be subdivided, can have sub-epics. So if you have a big job to be accomplished, you can have them into different sub-epics, or you can divide the epic into features. So if Lockheed Martins want to develop a new system, then they put it in epic. If it is so large, they divide it into sub-epics. And then from there, they start saying what are the features, because the feature becomes their own communication component that they need to deliver to. And if the feature is large, then they divide it to sprints under user stories. And those people who are working on each story, they can divide it into tasks and then implement them. But this is how it is done in Lockheed Martin. So each sprint include a daily Scrum meeting, as you know. Once a sprint is finished, they have a retrospective meeting also to evaluate and do quality control and plan their next sprint. I hope this clarifies the question. Okay, so nothing big deal about these terms. These are jargons used internally, but I mean, this issue of epic means something to engineers that are developing a complete large system, maybe for a new product, and then they need to look at the features and see how much of implementability they can use from their assets, already reusable assets, the artifacts. And then when they don't have it, they go into the development or modification of existing features. This is showing a sprint event. We don't have time here to go into details. You can read some about the daily Scrum meeting and what happens on the sprint demonstration and review, sprint retrospective. And this is their migration journey from old style, maybe waterfall mechanism of doing things like 4 months to develop a product and then have testing nightmare, to agility. Create agile at scale. When I told you about reducing the time and the teams, develop team efficiency. They have to make their team self-contained and efficient and lightweight, small number of people, optimize the organization. So they divided into 3 goals and they kept improving on these incrementally also. They used Scrum Pan, which helps you to move from legacy to agile by combining Scrum and Kanban, 2 techniques to develop this migration process. No company in the size of LM can develop this migration overnight or even over a month or 2. This could take maybe a year or 2 to achieve something meaningful because big organizations move slowly. Okay, I think this will include my discussion about Lockheed Martin, and I would like to move to, in the balance of this, to General Motors, talking about their automation issues and why they need them. Okay, so General Motors have, like Volvo and other automakers, a nightmare of handling software product lines and keeping track of variations in each system. And I mean, look at this feature model. It's just for front seat climate control feature. We're not talking even about the front seat. Under the front seat, climate control, the temperature, the things that you need to adjust on that seat would have such a feature model that you need to deal with. And in every model you sell, in every car you sell, it might have different configuration. So the variation points here are big issues. The configuration of a vehicle that will receive such a package is also a big challenge to manage. So General Motors decided to use gears. As you know, gears and pure variants, they own about 60% of the market of product line engineering automation. Feature IDE that you are using more into academia and research, but in the industry and in the business world, more implementing gears, especially in the States, and more of pure variant in Europe and other places. But anyway, they use gears from Big Lever company, and several, actually Lockheed Martin is also using gears. We haven't talked much about that. But let's see their experience here, what they do when they bring this automation to their operation. General Motors used a superset of artifacts here, their products, reusable products. And if you notice, there is a little dot here, we call it the gear, that help them do the configuration variation point. For example, if this is a feature, this is the extensibility point I mentioned, like the plastic extension or aspects. And in this asset warehouse, they develop their variations of products and features. So a subset supply chain of reusable digital assets is used. And the variation point is this, what we call it the gear, that you will see it here in the larger picture. So this is the feature, and this is the gear, the variation points. And it's being motivated and guided by your feature catalog. The feature catalog decide the variation points to create a product line. So when they do their feature catalog, they decide what type of product line they want to configure. And with that, they push whatever they have selected to the gear. The gear is nothing but a configuration management system. The configuration management system receives the features, and here is what's so-called feature catalog. The feature catalog also indicate what type of features are selected, what type of variations are selected from your catalog, from your artifacts, and it all goes to the configuration management along with the features variation to produce product A, product B, product C. This is how simply it's depicted, but it's a little bit more complex in reality because there are so many activities going on here and here and here. Okay. The key issue in General Motors is to change the bill of material, like in traditional sense, you know, in any factory, there is a bill of material. You want to build a car, car A, car B, car C, then it has a bill of material. The bill of material includes everything that this car will need. They want to replace it with the bill of features. Why do they want to do that? Because using features instead of materials is more constructive, more meaningful. So in these features, they can define all their artifacts. In these features, they can control all variability. In these features, they can design their feature model. They can do the variation points. They can keep the reusability of artifacts. They can make sure they are decoupled. They can make sure that they can be extensible and so on. And this is how the software works. Gears want to deal with features, bill of features. So there is a feature modeling construct provided by Gears, and GM is using this product line to work the following. They use it for feature declaration. So in their feature build, they do a feature declaration, which is a subsystem, a system of subsystem, and in that they can define the model of the car that they want to produce and what type of software will go into that, what type of control and artifacts. So they have the feature declaration, and then they have something called feature profile, which is specific to the profile and the parameters and how they instantiate the product. Now, let me a little bit talk about instantiating the feature. As we said, there are features in your artifacts, reusable features, and they sometimes instantiate the feature. That means to add variability points to it, to create a specific feature that they want. So they have basic feature or abstract feature. They instantiate it to produce a new feature that is specific to that model. So they have a feature profile. So when they get the feature from the feature declarations, then say, okay, we need to instantiate it. That means to make it specific to this product. And that's what happens. Assets are the abstractions of systems and software artifacts in the production line. So GM, when they call something asset, that means it's ready to go. It's been instantiated, it's been ready, and it's been designated for a specific model, specific type of car to go in. And we know now, by now, what's variation points. These are encapsulated for variations in the assets used to build the product. And we said they are done in a way that using aspects or PPC to make sure that you are not destroying the feature basic model, basic abstraction. You just add variation points to instantiate it and make a new feature. So this also shows you more details of how they do the develop their product from the assets. If you noticed here, they use the variation point, as I mentioned before. In this step here, you see the little gear. This is indicative of variation points. These are different use cases, different roles. You have an architect, you have a developer, you have a quality engineer, and they are applying their variation points to the products in the domain engineering, and they are pushing it to the configuration manager, the product configurator. And here you have your feature profile. If you remember the bill of features, here you define the profile of the feature, you feed it in the configuration system, and then the feature profile is defined here. As I mentioned in the previous slide, profile means instantiated feature. So you push them all to the product configuration to automatically design the actual product that GM wants to install in this product line. So the GM has a nightmare like others, Volvo and others, about assets traceability. So their artifacts is in maybe in millions, and they include the requirements, system architecture and designs, source code implementation, calibration, parameters, test cases, documentation. All of that you have to maintain, control, make easy access to it. So there are some common representation of variation points is key to achieving traceability from requirement. Let me talk something before the time catch us of something important to GM and even Lockheed Martin and all big companies, including Volvo. As I said, their ecosystem consists of thousands of subcontractors. These subcontractors, they don't come to your warehouse and build products. They deliver to you ready-made products to be assembled. You will gonna face a nightmare in your variation of features and designing new products and things, because these are not things that done under one roof. They are coming from other partners, other suppliers. Your vendors will deliver to you everything physically and electronically. So when you get an artifact, let's say you get a product, you get a chair, you get a motor, you get a control system, you get a dashboard, you get whatever you get. You want your tool. Let's say in this case, GM had or using gears. Your suppliers have to understand that since you are using gears, they have to deliver to you their assets compliant and compatible with gears, so that gears will be able to understand their artifacts and help you integrate the product. So this is how it happens. And you will see it in the following slide. I mentioned here that like Pure Variant, like even Feature IDE, they all have plugins. They all have the APIs. They all have the interface that is needed to enable them to connect with their, for example, General Motor here use Doors from IBM that will maintain their database. And Doors become like the interface between them and the supply chain. The supply chain ecosystem deal with Doors, send the documentation and everything, and connect directly to the systems of GM. And from Doors, it communicates directly with Gears. As you see here, this is the Gears system. This is the interface here, plug-in that Gears provide to interface with Doors. So what happens, Gears doesn't need to develop a plugin for every one of these, maybe 10,000 suppliers. It's impossible. So they go in between a broker, which is Doors. Doors would build these plugins. So if I'm a vendor planning to start supplying GM with something, I contact Doors, we build the interface, make sure that all our documentation or our knowledge base for our product and its integration with others will go through Doors. From Doors, there is a connection plugin to Gears, and this way, nothing is done manually. All things are coming and look alike from a development point of view as done under one roof. So these bridges are very important in the automation ecosystem. Maybe we don't see them in university, but in any setup in the industry, if you want to implement any tool, you have to ask first how I connect with my ecosystem, how I connect with my supply chain, how I'm going to do minimum overhead or any conflict with any product that I receive and make sure compatibility is preserved. I don't know, time is running, and this is in the roles that GM define in their product using gears. The most important role here is this guy here. It's the product line integration engineer. This person is responsible over creating the bill of features, as we mentioned. The bill of features will guide the configuration management in gears of how to build the products. So there are other important roles here, like the requirements and things, but all of this is designed into one ecosystem of management to help GM automate their system and produce results. So in conclusion, we have focused on features for variation and product selection. We have also talked about the automation process for product line. We talked about how GM wanted to migrate from bill of material to bill of features. We even did not have time to talk about the complexity problem, but you can read about it, moving from complexity of n squared to complexity of a straight n. And we talked lately about how big organizations organize their agile journey to be more agile. I want to check if somebody had any comment or question. Not yet. Okay. I really want to thank you and appreciate your patience. I hope this would shed some light. The slides were made intentionally more intensive so that would be self-explanatory for you. And I hope if anybody has a question or anything can send us an email or a comment. I appreciate it. Thank you very much and hope to see you again. Okay, goodbye.